Greetings everyone, welcome to another topic of compiler design, that is left factoring. We know a grammar is two types, that is deterministic and non-deterministic. In case of a non-deterministic, that is an example right here, the same term can come multiple times. As a result, we may have to do backtracking a lot of times. If we see the example here, this is an example of non-deterministic, and in here let's say I want AC. So what I have to do for this one, I can derive first A and then initially I get B, but I don't want B, I want C in this case. So what I have to do, I have to go back in here and then I have to go again A to C. Now here I have to backtrack multiple times if I have like this kind of scenarios. So to solve this problem, what we're going to do, we're going to do left factoring. So what does left factoring do? Left factoring does is that you don't have to backtrack anymore. We're going to create a system or in a format in which way that you don't have to backtrack, rather you can just move forward. Let's see what is it. This one is the format that we have seen here. Let's say alpha is common in multiple times, but along with it the beta part is different. So if this is the scenario, then what we're going to do, we're going to format it in these two ways. Here A equal to alpha A prime, and then this alpha is the common part in all the expressions, and A prime will be the beta parts that are different in all the terms. If we see the example, let's say this is an example here. To solve this, what we have to do, we have to first identify what are the common terms. So here this whole part is common in this term also. Yes, this is not common in here, but that's also not a problem because you have to only check the terms in which these are common. If there is a term which doesn't have the common terms, it's not a problem, it can stay right as it is. So what we're going to do, for solving this, what we have to initially we have to write, let's say S equal to, we're going to write, now this is the alpha part, we know this is the alpha part, this is the common part, and along with it this is the beta part, let's say B1. Now it doesn't have anything, so it's going to stay as it is. Now what we're going to do, we know the formula is alpha A prime. So here the alpha is the common term, so we're going to write I E T S, and along with it A prime, or which is its node, that is S prime. Now there is another term which is A doesn't have anything common, so what we're going to do, we're going to just write here A, since it doesn't have anything common. Now we're going to expand the S prime. What we're going to do, in S prime we're going to write the uncommon terms, that is for this one there isn't anything along with alpha, so we're going to write for this one epsilon, and for this one along with the common term there is E and S. So this is the beta part, so we're going to write E and S, and thus this is a solve. In this way we're going to solve the left factoring problem. So what does in here is that when S comes, first S take E T S. Now let's say I want this one. What it does is, let's say for S prime, it can directly choose this one. It doesn't have to go and check this epsilon or not. You can directly choose. For S prime it is ES. Or if I don't want ES, if I want epsilon, then it was just gonna take epsilon. That's simple. This is the same problem, we just got another. The answer will be the same, just we're going to add E equal to B in the end. The rest of the answers is same. This is another example. Let's see. For A term, what are the common terms? I can see A is common here, so this will be alpha and this will be beta 1. For B, there is BB, so this is gonna be the common terms alpha, and this is the uncommon, let's say this one also beta 1. Let us expand A. If we expand A, what we're going to do, we're going to get A, which is the alpha part, and A prime, and we're going to expand A prime to what? For this one AB, and for the later one A, and thus it is solved. Now the B term, what we're going to write here, B equal to the common terms B and B prime. From B prime, what we're going to find B, and there is nothing with this term, so it's going to be epsilon, and thus we have solved this problem also. Let's check another problem. So this is also similar problem. Let's see. So A. So A is the common term, so I'm going to write here A and A prime. Now you can see that there is A in these two parts, so we might have skipped this one, but that's not the rules. If we have one word that is common in all the terms, we have to take that term only. So we're going to take only A, not small a, capital A, only the small a. And then what we're going to do, we're going to expand it. Expand it how? For this one we have AB, so we're going to write Along with this, for this one there is a, and for this one there is nothing. For the last one there will be epsilon. Let's see another problem. For this one t is common, so let's write equal to t and e prime. We're going to expand e prime to plus c or t. So it won't be t, it will be epsilon, because it doesn't have any term along with it. And let's see this problem. Okay, so I can see that a doesn't have anything common with it, so this term is, let's check this term. Let's see this one, bs, then b comes, there is bs but s, there's bs but s. So until this term only two letters are common, so we're going to take the first two letters. These are going to be alpha and the rest will be beta 1, beta 2 and beta 3. So let's write here s equal to bs s prime or a. Now what we're going to do, we're going to expand the s prime, s a s or s a s b or b. Now if we see carefully, we can see here that it also has something common, like this SA and SA, these terms are common, so we can further extend it. So let's see, if I have this kind of situations, then we can further expand it. So let's expand here. This I'm going to write again, s equal to bs s prime the s prime. Now since there are again some common terms here, what I'm going to do, I'm going to take the common terms SA and take another s double prime, and along with it there will be a b. Now I'm going to expand this s double prime. What are going to be as or sb. Thus I hope that you understand how we can do left factoring, and from using left factoring, what we can do, we can change a grammar from non-deterministic to deterministic. That is all. I hope you understand the left factoring. Try these examples. If you still have any kind of problems, to comment below. Thank you.